Welcome back. Off to
Fix your Git.
fix your Git. Absolutely. Here it is. James, off to you first.
So basically, we're going to spend the rest of our time doing some things that don't really fit into the main sections of Git, right? The main learnings and undertakings of Git. They're still vastly important when you're using Git. And the first section is undoing things, right? What if we accidentally do something that we want to revert, or such as unstaging a file or amending a commit? That sort of thing. So just to get started, the first thing we talk about is changing your last commit. Let's say you committed something, but you forgot to stage a file, right? Which can obviously happen pretty easily. Or if we put in the wrong commit message, right? We accidentally committed something and we only got half the message written down. A simple command that just says git commit dash amend will let you just add to that last commit, and it'll redo the hash for you, right? So if you commit something and say, oh shoot, I forgot something, I forgot to stage something before I committed, just say git commit dash amend, but make sure you stage before you do the amend. Otherwise you'll miss it again. But it'll just pop right in there, and it basically just appends to the last commit, amends to it, right? Really easy to do.
And there's nothing wrong if you're working on one thing and trying out thing after thing after thing after thing to just amend. Yeah. It's not criminal. No. That gives you a nice clean one thing, and you don't have to do a cherry pick or a rebase with squash.
Yeah. So. The next one is unstaging a file. Let's say we staged something when we didn't really, want to, right? Because the staging area is really where we're preparing to commit something, right? So if we accidentally stage something that we don't want to add to this particular commit, we maybe want to add it to the next commit. Simple command. Again, you can find this command when you write git status. It's really easy. It'll show up right there. It just says git reset head and then the file name. And what it'll do is just unstage it. It won't do anything to the file itself. It'll just move it out of the staging area for you.
Yep.
And then finally, unmodifying a file, right? If you want to do, right, if you do a bunch of stuff and you're like, that's not going to work, I don't want to do any of that. Basically, this is what undo pending changes does in TFVC or something like that.
Or if you're in Visual Studio.
Yeah.
Visual Studio has an undo. Hit undo and it just undoes
it. Does the git checkout dash file name, right? Yep. And that will revert all the changes on a file back to the unmodified state of the last commit, right? So let's just jump in and do this real quick. So I have my Git repo, right? And I'm just going to say git log, one line. Just take a look at it. Awesome. So the first thing is we want to take a look at amending a commit. So let's say I modify both my index and my fun, or my foo.txt. Let's do that. So notepad index.html, come in here and just say I want to get rid of the fourth paragraph. Save it and close. Notepad foo.txt, and get rid of that line. Now let's say I only add my index and stage my index file. So I go and say git add index, and I forget to stage my other one, and I just go ahead and commit. Oops. And there we go. And now, I meant to add my foo.txt. So what we can do is we want to stage that foo.txt and then amend the commit. So we'll say git add foo.txt and git commit amend. And that drops me into here. We can see that this is actually the commit, the commit message that we just had. And we want to say remove, oops. Sorry. There we go. Remove, I'm not as, there we go.
Not as familiar with VI.
Yeah, I'm not as familiar with VI, so I'm just going to go ahead and write it. That's good enough for me. And now we can go ahead and look at the history again. Git log one line. And we can see that we only have one commit here, right? Remove fourth paragraph from index rather than two commits. And so that's what git amend does. Now, let's unstage a file. So I'm just going to say git or notepad index. I'll just add another paragraph here, right? close it. We now have that, and let's stage it. Git add index. It's now staged. How do we unstage it? Again, if we just write git status, just like that, it'll show us how do we undo that. Git reset head, and then the file name. Just like that, it's unstaged. Easy. Now, how do we unmodify that file? Again, git status, right? Git checkout -- file name, right there. And now it's unmodified, and we're back to a clean working directory yet again, right? So a lot of these commands are really, really easy to find if you just type git status, right? And depending on what stages or what states your files are in, running a git status will not only tell you where they are, but what commands can you run against them to do common things.
Can we do a stupid git trick?
Yeah.
Can you go back to your thing, or it's a great git trick actually. Could you go back? You did the git log.
Yes.
And you did one line in there, and then you had some magical stuff that you typed at the end of that to get the graphs and all that.
Yes.
Could you put that in there again? Could you type that one more time?
Yeah. So git log -- graph. So the graph option. I'll walk through each option, right? So the graph option will basically create ASCII art of what the Git branches look like, right?
Yeah.
So it's like a terminal version of Git K. One line is it pushes the Git commits into one line rather than multiple lines for each commit.
Because it's really hard to read the graph
Yeah.
if it's spread across those. Yep.
Yep. The next one is decorate. So what decorate does is it actually puts in where the different basically pointers are, right? Branches, tags, where your head's at, that sort of thing. It actually will decorate that in the graph itself and within the commits as well. It'll also show you where your remote branches are too. And then the last one is all, because you want to make sure you have every single one of the branches in there to see where those are. And if we do that, we can see we have all of our commits here. We have the tree on the bottom left. And then part of the commits here, we see that we have like secondary master, origin head are all sitting at one commit. So on and so forth. So we can actually see where everything is straight from the command line. We don't have to pop out to git K or some client that has a visualization of it.
I can never remember graph, one line, decorate all. So can you do me one favor?
Yep.
Can you type git config -- global alias dot glog, graphical log.
Okay.
Space quote log, and then -- graph -- one line -- decorate -- all.
Yep.
Because it's too much for me to remember all that stuff. And hit enter. Now just type git glog. What? Git config global alias glog. Oh, your graph has an error in it.
Yep.
So just there you go.
My apologies.
You're just trying to make me look bad.
Obviously.
There it is. Git glog.
Perfect.
Now you got git glog. Git glog would be the shortcut for that. I use glog for graphical log. It's a stupid thing. Glog sounds even terrible. But you can create these aliases, and if you go out on Bing or anywhere on the interwebs, you can search for people's aliases, and some people have these giant things of really cool aliases that they use to just kind of simplify their workflow. You're going to start wanting to create these aliases, and that's how you create them. It's very, very straightforward. Mm-hmm. Good. Thanks for that. I just wanted to take that as a quick option.
Yep. So the next thing is tagging, right? So tagging is pretty important as well within any version control system, right? In TFVC we call them labels, but again they're treated pretty differently here within Git, right? So there's two types of tags, right? There's annotated versus lightweight, and it's kind of difficult to see there. But annotated is a full object, right? It's just like a commit. It has name, email, date, what the message is. And this is kind of the recommended way, right? This is where we want to tag a specific commit and say this is version 1, right? And then we also have our lightweight ones, which are just a pointer to a commit, just like a branch file, right? No metadata, kind of temporary things to just mark a commit so that you want to temporarily keep track of, right?
And you can sign tags too on the annotated ones.
Just like signing your commits or signing who you are, you can sign tags as well.
Yep. You can say this is my tag. I Stephen Borg, am validating that this is the version 1.
Yep.
Perfect. All right.
So how do you view tags? Just git tag, and the tags will be listed, just like a lot of things like git log, that sort of thing. You can use patterns using the -l, right? There's a bunch of switches, and again, like Steve said earlier, you can just use --help on any one of the git commands, and it'll bring you out to a web page that'll show you the manual page for that. And the thing about viewing tags that you do have to note is that they're in alphabetical order. They're not in a date order, right? Alphabetically ordered.
Yep.
Kind of throws people sometimes. So what are some common switches? The first one is -a, which basically depicts that this tag is going to be an annotated tag. -m is just like when we're doing git commit -m, we can just put the tag message right in there. And then lightweight tagging is -lw to specify that's a lightweight tag. By default, it'll just be an annotated tag. So, how do you create tags? Git tag -a, tag name, -m, and then you get the message, right? Lightweight tags, all you have to do is put the title in, right? There's not a lot of stuff around it, so you just say git tag, whatever it is, -lw, and you're good to go. Easy as that. That's what that does is that tags your current commit. If you want to tag other commits, you just specify whatever the hash is, right? And notice that the example in the PowerPoint is a snippet of the hash. You just have to go enough. You just have to use enough characters in the hash that it's unique across the repository, right?
And at least 5.
At least,
I think there's a minimum of 5.
I don't. It might be.
I might be wrong, but
Yeah.
I think it's a minimum of 5.
Okay.
Maybe it's a minimum of 4. I know there's a minimum. You can't just say a.
Yeah.
Even if it's unique. There's a minimum. Don't know what it is.
Yeah. And sharing tags, right? So tags are not pushed like with branches, right? You have to specify if you want to push a tag up to a public repository, right? Pushing a specific tag, you just say git push the remote and then the tag name. To push all the tags, git push remote -- tags, right? But just to know that when you push branches and you push commits, it's not going to push your tags. They're separate. There are commands to push them all at once, but yeah. So demo.
Is it worth doing a demo for tags?
I don't think so.
I mean, really, it's like creating a branch, except it's got annotations around it.
Yep.
I get tag. I think it's just one of those things. We can merge to a tag. You can move to a tag. I might be even able.
You can even check out a tag.
You can check out a tag.
It's basically you can really think of it as a read-only branch.
Yep.
Right?
Or a not movable branch.
Yes.
You have a tag.
Movable.
You can't move. You can't do a commit and it won't move with you.
Yep.
You go to a tag and that's it.
Yep.
All right. Let's hit the next one. What's on deck?
Alrighty. So what we have is cherry pick, bisect, stash, revert, and reset. So these are just a few of them, and we're going to kind of go walk through them and then do a quick demo on each one of them. So cherry pick is basically, I want to pick up a commit on another branch and just apply it to mine.
Just one
Just
thing.
one.
Yep.
Just one. And you can do one or multiple of them. But basically you just say git checkout master, git cherry pick, and then you just get the short hash, the snippet of the hash, and then you can kind of look at it, right?
Or you might have, for instance, a tag that you could pull a tag as well.
Yep. So what this looks like is I'm on master. I run a git cherry pick C3, and it just basically, you can think of it as somewhat as a cherry picking rebase, sort of, right?
In fact, you could do a rebase basically off of that instead if you want.
Yeah.
Mm-hmm. Let's do all of the demos at once. Can we do all the demos at once? Just kind of go through those because I'm going to do those demos inside of pCodl because that visualization can, I think, help people understand.
Sounds great. Sounds great. So we'll just skip the demos until the very end.
Yep.
The next one is bisect.
I love bisect.
Yeah.
This is, you go in to find a bug in a commit with a binary search. So let's say you've started coding and you had a test that was working back in your 4th commit. And you've done 400 commits since then, and you run the test again as part of your regression suite. You're like, oh, crud, it failed. Where did it fail? Was it commit 5? Was it your last commit? What you do is you run git bisect. That puts you into a whole separate mode. We're not going to demo this. It's too much. But you say git bisect. It puts you in a whole other mode. And then you go in and you say good bisect, git bisect good. I think it's good.
Yep.
Where you put in where you knew it was good. Change set 4. or you pass in, not change set, but commit for
the hash.
The hash. You put in the hash. Then you say commit 400 was bad.
Yep.
And what git bisect does is it will go to the middle. It'll get you the middle commit, make the middle commit active inside of your directory. You run the test, and then you pass in, did it fail or pass? If it failed, it then goes up another chunk. It bisects it again. And it goes halfway in between, and then you run the test again, and if it succeeds, then it goes halfway in between.
Yep.
And it just keeps following it in until you, a binary search algorithm, if you will, to narrow it down and find it. How cool is that for a version control system to have? That's why I wanted to talk about it. You're like, pull that out. I want to do one last thing. Let's say that you had a unit test that was passing at 4 and failing at 400. Now, if it was a unit test, really, and you didn't run it for 400 check-ins, that would be a bad juju. But let's say that you did. Or let's say it's a UI test or some automated test. You can also pass in a command line that will run an automated test. So what bisect does is it will automatically go to the middle, run the test. If it fails, it'll go back. If it succeeds, it chops itself down and automatically will come down, bam. This is the commit where you broke it. Then you look at the history between that one and the prior commit, boom, you're in. Sorry, I just think that's so smoking
that is
cool.
awesome.
I was like, who puts that in a version control system?
Amazing.
I know. All right.
Stash. So stash is basically a way to switch branches without committing work, right? So think back to the example that we had before where we're working on a feature and we get that call. Steve calls me up and says there's a production bug that we need to fix immediately, but you're not ready to even do one commit for your feature yet. Your code doesn't even compile. So what we want to do is we stash it, and it stashes it for us, and we can switch branches. And do our work, come back, and then unstash it. You can think of it as somewhat as a suspend resume of your work, if you're familiar with that within Visual Studio, or somewhat as a local shelve set, right? You can shelve your work, switch somewhere else, do some work, come back, and then unshelve it, right? Really, really easy to do. So, right, master, we stash it out, and then once we're ready to grab it, we just say git stash, bring it in. And we're good to go.
That's perfect. Stash is useful if you are like me and keep a bunch of stuff just on your desktop.
Yep.
And you kind of want to move it, but you don't want the desktop to be clean. If I drop in 15 files on my desktop and then I switch branches, those 15 files are still there, right? If I haven't committed them to the latest desktop or whatnot. So by stashing it, they just go away. And then I can get to clean desktop and run from there. So stash, useful for that too.
Again, we really care about having a clean working directory. Some of us do.
Or a clean working desktop too.
Yeah,
I don't know.
Yeah.
All right. Revert. Revert creates a new commit, and it's basically a compensating transaction. This is what you have in Team Foundation version control. So you've got some code, you change the code, and you're like, uh-oh, I want to go back to this previous version. In Team Foundation version control, it creates a new check-in that basically undoes all the stuff you did. It's a compensating transaction, compensating check-in for that. Adds new history, doesn't modify existing history. It just reverts it. Reverts it back. There's a corresponding thing called reset. I think that's the next one. And if you want to hit the next slide, we'll go to the reset. Well, this revert. I'm going to demo this anyway.
Yep.
There it is. So that was reset you showed, which is like get rid of this.
Yep.
And you didn't mention this, but there's get reset hard. And get reset hard is like, go back, and I never want to see that stuff again. It's just get it out of my history. It's gone. I don't want it there. So reset can also bring things back. We'll take a look at that in just a moment.
Yep, and this is what reset does.
Yep, kind of goes back and deletes it. All right, reset versus revert. I just mentioned it, a compensating transaction versus a reset, and we're actually going to take a look at this. So this is a time to go on to a demo. So if you come over to my slide this time, or my desktop, we'll be able to see a demo, and I'm going to go back to pCoddle. I don't know what you call it, but this is a great tool. By the way, if you're trying to get here and you're using IE, it doesn't work in the later versions of Internet Explorer. This is a fairly old tool. It's been around for a long time, and there's some incompatibilities and non-standard things that it tries to do, and IE is trying to break that dependency on those non-standard things. So you got to download Chrome or something that can handle the old styles of doing things. Anyway, here I am. There's master. Now let's give it a shot. Git commit. Git commit. Git commit. Git commit. Let's now start playing. Right? We need to get back to 3. So we can do git revert C3. Voila, it makes a change and moves master forward. Now C3 prime is exactly identical to C3, basically, except
it's the opposite.
Yeah, it's the opposite. It's a change. But if I looked at the file system, my working directory would be identical in C3 and C3 prime, because it basically undoes everything that was done in C4 and C5. Now, I can look at that and go, ugh, I don't want any of that history. I don't want it to even point to C5. That was such an embarrassing commit. I don't want anybody to ever see that commit. So in that case, I'll do git reset C3. Now in this case, it's going to go back and it's going to highlight all of that stuff, and it's gone.
There's the difference.
There's the difference. But oh crud, I boo-booed. I said I wanted to get rid of C5, and I just blew away C4. How do you get back to C4? You've done a reset. Well, that history's still there.
Yep.
It's just hard to find. You've got to go type in git reflog --1. It's just like log, but it's the whole stuff, even stuff you've thrown away.
Yep.
It's not accessible. And then you can find C4. You can find that hash, and then I'm going to recover it. This is kind of fixing your Git. If I need to recover that, let me go in and recover it briefly. So I'm going to do something like git checkout C4. Boom, my head is now on C4. I've got a disconnected head.
Yep.
Now I'm going to have to create a branch, git branch, save me. Got a branch, git checkout. I guess I could just go right up to master, git checkout master, and then git merge save me. Boom.
Saved.
Saved. I've got it back, right? And then git branch dash D save me. That's how you can go back and kind of recover some of those things if you've like literally have blown something away. Now let me just do a quick reset here and clear, and do a couple more things. Let me do a git checkout foo and git commit. Do a few of those, and git checkout master. And again, a few commits. There we go. And now I'm like, you know what? I'm not ready to pull in foo yet, but I made a change in C3 to one of my things that's really important, and I want to get that over. So let me do a quick git cherry pick C3. Boom. And it'll pull it over and add it there.
Yep.
So now I've got it over there. But now what happens if I merge? Now I've got it in two places. I made my change. Do you want to take a guess? Merge isn't going to do anything, right? Because it creates a new one. And even rebase isn't surprising. There's nothing that happens here. So let me do a quick git checkout foo, and then git rebase master.
Just picks up the other two?
Just picks up the other two. It's already taken 3, doesn't need to be over, so it picks it up and off it goes. So
awesome.
Nothing surprising. You've already pulled it over. No sense pulling it over again. Off you are.
Yep.
Git merge, of course, we've just created another one. That is a demo of those things. Was there something else I needed to demo in here? I think that was it. I did cherry picking.
Yep.
I did rebasing. Reverting. Stash I can't do in this UI in here. Stash is just to throw things into a repository anyway.
Other than that, we're good.
I think so. I want to make sure that we have time to kind of wrap things up, because I'd like a time check. What's the time check, Barry? What do we have in terms of minutes left?
Take what you need.
All right. Take what we need, but we're getting close. We don't want to have the janitors coming in and kicking us out or sweeping around us or making noise. What I want to just kind of reflect on what we've done today. And we've gone through and we've laid out a lot of the things about Git. And I hope we approached it in a way that wasn't daunting, but also kind of walked through some of the basics and why you might want to do things. Some of the learning pieces as we went along and kind of just try to get a good understanding of it. There is so much more to Git than we've explained here. There are some great resources. pCodl is a great resource for just kind of visualizing things like we've seen. I would also recommend you go to git-scm, git-scm.org, and there's a curated list of absolutely awesome walkthroughs. I like Rise, R-Y, apostrophe S. He or she, I don't know, created a really nice walkthrough that helps you kind of understand what Git is and kind of get your fingers on the keyboard. That's part of how you learn Git is just fingers on keyboard so that you kind of get that and just going and then just using it on a day-to-day basis.
Yeah, I'm a huge fan of on the same site, git-scm.org. They have a book. It's an open source book that they actually use Git to develop the book, which is kind of cool that they do that themselves. But a great read to just read the first 5 chapters are a lot of surface, just like understanding it, and then the rest is very deep level understanding how Git works underneath.
Yeah, it is. And it's nice to have that deep understanding of how it works and why it was created and those sorts of things. It was written a long time ago, several versions back, so some things don't apply, but most do.
Yeah.
Most do. The underlying infrastructure is kind of the same. I would like to go back to the screen briefly to take you to git-scm.org. Here's where you might find all of them. Here's the latest release. Notice how late that was. I mean, just really recently.
That was... Yeah,
just a month ago. There's about will compare it to other source control systems, and not in a disparaging way. This isn't a flame that you're getting thrown out. Downloads here, a community to get involved. I want to take you to documentation, and if you go to documentation, you can see a reference manual. And this is the book. This is the whole book, and you can go to download it right here. And then what you can do on here is, at the bottom, there's an external link section. And it's the curated one. And here's Rise Git tutorial and the diving deeper. Here's the short and sweet ones. These are good. Here's the other ones. Git Draw was one that was just recently added. I'm going to click it just because it's kind of cool. If you take a tiny repository, like Git init, and then you just create these very small things, you can see what the whole repository, it visualizes the repository. Cool. I know, it is so incredibly cool. Don't try to do this with a very large repository or even a medium. Even things that have like 15 commits are just overwhelming. But that kind of a thing is great. And so I'd really recommend that. Again, Rise Git tutorial. If you're a computer scientist person, you kind of want to learn about directed acyclic graphs and how those contribute. That's where it is there. Great place for that. Any other finals before we wrap on the rest of the MVAs?
No, I'm good.
Okay. What I want to wrap up with a quick discussion on what's coming next. So last week we did Kanban. That one was very different than this one. That one was, we built a Kanban board on the wall. We did a bunch of things around very much a process feel. And we didn't do much with tools or technology. This session, on the other hand, moved to more of a technical view of how can you take Git and bring it into your workflow. The one next week is on the theory of lean. It's Lean Fundamentals. I highly recommend that if you have kind of an analytical mind, but you're also very interested in lean and agile methodologies and why they work. So there's the Kanban one a week ago talked a lot to people who like to learn from stories. They like to learn from kind of an understanding of how have other people done it. I want to see that and see that other people have had success, and then I'll try to replicate that success based on what they've done. There's a whole subset of people that don't think like that, that want to say, that's just other people. You're just cherry picking good stories. Let me see why it works. what are the fundamental underlying principles as to why Lean and Agile work? That's what we talk about. So we talk about diving into maybe even a wee bit of math. I promise it's not that painful. But it's the fundamentals of Lean. Moving off of that, there's the fourth in the series, and that really builds on the Kanban and the fundamentals of Lean, and it takes agility beyond the team and brings it to the enterprise. So here we're going to take some lessons learned from places that have implemented Agile throughout a large organization and talk about the difficulties of elevating it up through the organization, or even difficulties starting at the very top and bringing it down. It's harmful and difficult both ways. And then after that, we're back to another both process and tool related one that's on release management. And the release management one, we'll talk more about the release management tool that's new from Microsoft, as well as how that fits into a continuous delivery model. So I highly encourage you to take your time and check out those and see which of those are going to be valuable for you. Now, before we go, I want to remind you there's a poll. There's a final poll there. Please fill out the poll. I'm very interested. Yeah. I'm at Stephen Borg at Twitter, and James is
James Tupper
at Twitter.
Yeah, very easy.
We want to say, give a huge thank you for sticking with us through the day and learning it.
Oh, thank you to Sachi and Andrew as well for fielding questions for us.
Oh, yes, absolutely. Really appreciate that. And all the other people that provided answers and comments on the questions. We just got some great ones. The GitHub workflow and several others that I just really appreciate those answers. So thanks, and a shout out to all of you and the attendees and the people who helped answer questions. Thanks.
Thank you.